Okay, let's dive in. We've got a really interesting story today, maybe a bit of a cautionary one, actually, from someone's home garden. It's all about plant hormones and what can happen when things go, well, a little sideways.
Yeah.
We're looking at some gardening notes here, someone experimenting with gibberellic acid, GA3, on mint plants, and the outcome was quite something. So our mission here is to figure out what exactly went wrong based on these observations, understand this hormone's effects, especially maybe when overused, and see what it tells us about plant growth overall.
Absolutely. It's a fascinating glimpse into just how powerful these plant growth regulators are. Things like GA3, they operate in such tiny amounts, but the effects, huge. These notes really highlight that delicate balance.
Right, so the core problem the gardener immediately flagged in these notes was seeing some unexpected side effects after putting the GA3 on the mint. And right away, they suspected they'd just used too much, that the application was, excessive.
Well, that suspicion lines up perfectly with what GA3 actually does in a plant. Its main job, fundamentally, is promoting cell elongation. It essentially signals cells, especially in the stems, to stretch out, get longer.
Okay, cell elongation. And according to these notes, that effect wasn't subtle at all. It was pretty extreme. The notes mention really excessive stem elongation, particularly on the new growth coming from the nodes, the little joints on the stem.
Exactly. Those points just took off vertically.
Yeah, the gardener described the mint becoming super leggy.
Mm.
We've probably all seen that look, right? Like seedlings stretching for light, tall, thin, kind of weak-looking stems.
And what really defines that legginess, as the notes point out, is the internode length, the spaces between the leaf nodes on the stem. Those got stretched way out.
Okay. So longer spaces between the leaves, making the whole plant look stretched.
Precisely. And that stretching, that rapid elongation, it has a real physical consequence. When those cells stretch out too much, too fast, without enough time for structural reinforcement, well, the stems just don't develop the necessary strength. They become thin and weak.
Right, structurally weak.
Yeah.
And that led directly to what the gardener called lodging. Is that right?
That's the term, yes, lodging. It's when the stems just can't hold themselves up anymore. They become too weak to support the plant's own weight and just flop over. They lodge against the ground or each other.
So that visual of the mint falling over is a direct result of the hormone causing too much, too weak elongation.
Exactly. It's a clear sign that the structural integrity was compromised.
And connecting back to the gardener's own thinking in these notes, their conclusion was pretty immediate, wasn't it? They figured the solution just needed to be way more diluted.
Which is spot on. It really drives home how crucial the dosage is with these compounds. It's potent stuff. Getting it wrong, applying too much, isn't just ineffective. It can be actively harmful to the plant structure, as we see here.
So it sounds like a harsh lesson learned. Did the notes mention future plans? Yeah, they did. The gardener apparently planned to keep experimenting, but focusing really carefully on the application, getting that dilution right, and maybe targeting specific growth stages. The notes mention seed germination specifically.
Which makes sense. GA3 is naturally involved in breaking seed dormancy, so controlled application, there is a known horticultural practice. It's about using it appropriately.
Okay, so pulling it all together from this gardener's notes, the big takeaway seems to be that even with something beneficial, like a growth hormone, pushing too hard, too much GA3 in this case, it just backfires. Instead of lush, strong growth, you get these weak, leggy stems that just collapse. Lodging. It really shows the power, but also the need for precision.
It really does, and it makes you think, doesn't it? If just tweaking one chemical signal, even a tiny bit too much, can so drastically change a plant's physical form and its strength, what else is going on? What other, maybe less obvious factors in a plant's environment, tiny changes in light or temperature or nutrients might be shaping them in profound ways we just don't notice day to day? What other critical balances are at play?